So again, the same concepts are going to apply. You're going to be able to use mostly elimination. You're going to want to mostly use elimination. There's several different types of these systems. We're going to stick with sort of the most basic ones. And so hopefully you'll be able to follow. So the first few slides are just about the steps that you're going to follow. Okay, so the first step you're going to follow is you're going to use elimination to get two pairs of the equations down to two variables to create a new system of two equations. So go ahead and write that down, and then I'll explain really what that means. What this really means, okay, we have a system of three equations, which means now we have three unknowns. So most of the time there's going to be an x, a y, and a z. Might be other letters, but there's going to be three variables now. So the number of equations that you need has to be equal to the number of variables that you have. So before we did systems of two equations, there were always two unknowns. So that was all we needed were two equations in order to solve it. Okay? With three unknowns, I have to have three equations. So that's the situation that we have here. Okay? But you can't solve a system of three equations, at least in this section. You can't solve a system of three equations with all three equations. We actually have to get it down to a system of two equations. And then we solve that like we did before. So the way that we do that is we actually pair them up. And we pair them up two different ways. Okay? And so we're going to take two of the equations and get them down to two variables. And then we're going to take two other equations and we're going to get those down to the same two variables. Okay? And then we'll be able to solve that system. So it'll make more sense when you see it, but that's the general idea of what we're trying to do. Okay? And so once you do that, you're going to solve that new system. You'll have created a new system that only has two variables. You'll solve that just like we did in 3.1. Okay? And whatever method you want to use to do it is fine with me. In general, I would say typically the most useful method to use when we get to this point is elimination, which I know you like, so that's good. So then once you solve that system, so you're going to find out two of the variables, right? That's what solving a system of two equations gets you. You figure out what those two variables are. From there, you can actually now find the third variable. Okay? And so what you're going to do is you're going to take those two, you're going to plug it into an original equation, and that's how you'll find the third variable. The best thing to do is actually work through a problem. So go ahead and write that system down. Make sure you get all your signs right. Make sure you get your order right and everything. And then I'll walk you through how to tackle this system. So here's what we're going to do. Okay, we're going to eliminate one variable. We're going to take two different pairs of equations to eliminate one variable. Okay. Now here's the thing. You can choose any variable you want to eliminate. What I would recommend is looking for, I don't know, one of the variables that seems easier than the others to get rid of. Maybe that would require fewer multiplications. Okay, so that's the first thing. And so is there a variable up here that seems like maybe it might be easier to get rid of? Tom?
Why?
Why do you say that?
Because, like,
Why?
smaller.
What do you mean? You're right. I agree with you. I need a good explanation as to why you think Y is the one to go. There's something standing out to you, right?
Yeah.
What is it?
The one in the middle doesn't have a number already.
Yeah, right here. Okay. So that one right there doesn't have a constant or a coefficient other than 1, which means I can easily multiply it by 2 to make it cancel here, and I can multiply it by 3 to get it to cancel there. Okay? So if you can find a situation like this, use it. It's going to make your life easier because you're not going to have as many multiplications to have to do. So with that being said, what I really am going to do is I'm going to combine 1 and 2 together. I'm going to then combine 2 and 3 together to get rid of the y's. So that's when we talk about the two pairs. We're going to have to pair up each equation. We're going to have to come up with two different pairs of equations. Question?
Could you like multiply the top one by -1 and then get 2y plus y, and then like that would be 3y, and then minus 3y that cancels? Can you do that?
multiplying the top one by negative 1.
Yeah.
Then you get 2y.
And then it'd be 2y plus 1 together.
Yeah, but it would cancel out otherwise.
Oh, you want to try to add all 3 together?
Yeah, can you do that?
Yeah.
Yeah, you could.
I think that'd be easy.
All right, hold on. Let me think about it. So you want to do the first one by
Maybe.
2. All right. So what he's saying is multiply the top one and then add all 3 together. You know what?
Oh.
It works, but here's the problem. That will only get you one equation. So when I add them all together, yes, you're right, the y's will cancel, but I will still only have one equation. I'm still going to need another equation. So instead of necessarily doing that, while that works to get rid of the y's, it still only leaves me one equation with 2 variables, right? It'll be an equation with x and an equation with z. And so I'm still going to need another equation with x and z. So while you could do that, sure, there's still going to be a second part to it, okay? All right, so let's look at what that was. So here's what we're doing, okay, what we've been talking about. Eliminate one variable by using 2 pairs of equations. We've gone through and talked about that already, okay? And we've talked about why we're going to eliminate the y's, okay? So from here, what you have to do is create 2 equation pairs. And since we've identified this middle equation as the one that's going to keep getting multiplied, what I'm going to do is I'm going to pair it with the top equation, and then I'm also going to pair it with the bottom equation. So it kind of will look like this. Okay? So the top equation and the middle equation on the left, the middle equation and the bottom equation on the right. And so I'm going to take those pairs, and they're going to turn into the one on the left will turn into an equation with just x and z. The one on the right will turn into an equation with just x and z. Then I can bring those together and solve that system. So go ahead and write that down, and then we'll work through it. You'll work through it. So in this left equation, I'm going to multiply this bottom by 2 to get the y's to go away. On the right, I'm going to multiply the top equation by 3 to get the y's to go away. So again, I'm creating 2 new equations with just x and z. How many just want me to let you work? How many have already started working and you're going? Okay, good. So here's with the multiplication. If you need this, so what happens is when I combine those 2 equations together, the y's cancel out here, the y's cancel out here, and I'm left with 2 new equations. So again, that multiplying the bottom equation by 2, and then I'm going to add these all together, and the y's cancel. And over here, I'm going to multiply the top equation by 3, add them all together, the y's cancel. So you'll have 2 equations with just x and z that you need to solve. And you can go ahead and do that. I will put it up there. And then you bring those 2 equations together, okay, and solve it. Okay? So let me go back to where I was so you can see where this all came from. So again, once you get them down, those 3 equations down to 2 equations with 2 unknowns, now it's just a system from 3.1. It could have been a question on your quiz, same idea. What you should have gotten for x and z is x equals -1, z equals 7. Raise your hand if you got that. Okay, that's good. So once you've done that, okay, all we have to do is find y. So from there, it's just a matter of plugging those 2 variables that you found into one of the original equations, and then you can solve for that missing 3rd variable. Okay, and that's what this says. Choose an equation. It doesn't matter which. Make it an original one of the 3 original ones. Plug those in. If you want to check, okay, after you find, in this case, y, you can plug -1 and 7 into a different equation and make sure y still equals the same value that you got from the one you chose. Okay. So I went ahead and I chose the middle equation. So I plug -1 in here for x, 7 in for z, and now it's just a matter of solving this equation for y. Okay. How many of you already finished that? All right. Those of you who didn't finish it, finish it. How many got that? Y equals -5. If you're still working, that's okay. So the question came up, do you still write it as an ordered pair? Okay. let's think about this now. When you have three variables, okay, we're talking about three dimensions when we look at a graph. Okay, when we had two variables, we were talking about x and a y. We're talking about straight lines on a grid that we can write. Cartesian coordinate system, just x and y. It's two dimensions. It's flat, right? When you have three variables, we're talking about three dimensions. So you guys who are in geometry now, or already took geometry, think about it in terms of a plane. So instead of each equation representing a line that crosses somewhere, now we're talking about three planes that are going to cross somewhere. Okay, and typically they're going to cross as a line. Okay, and the best way to sort of illustrate it is if you just look at the corner of the room. You got a plane as that wall, plane here, and plane on the floor, for example. They all intersect on this edge right there. So that x, y, and z represent that line. Okay. So the question, the answer is yes, you write it as an ordered pair. It's not a pair anymore though. It's an ordered triple. Okay. Final answer is actually -1, and you still go alphabetical, x, y, z. -1, comma, -5, comma, 7. So now we have length, width, and depth. Questions about what we do? Yes, ma'am.
We'll never have to like graph that, right?
I'm not going to have you graph. I mean, at some point, yes, you will be doing graphing in your mathematical future. We're not going to do that. Other questions?